Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 74 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R for Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you a new feature, a new very powerful feature that we can get from PyQt 5 as we're running it under Python in Thonny on the PC. Now, what have we learned so far using PyQt 5? We've kind of learned the basic framework and hierarchy for the program. We've learned how to make push buttons. We've learned how to make toggle buttons. We've learned how to make slider bars. And then we've learned how to connect that up to our Arduino project over UDP Wi-Fi so that we can begin to control our Arduino project from our cool graphical interface on our desktop. And so that has been really neat. Now, we've done very well with the widgets that we would need to control something, but a lot of times what are we going to be doing? We're going to be getting data back from the Arduino. So what I'm going to show you today is how to plot live data on our PyQt 5 widget. Now, today I am not going to hook it up to the Arduino project because I know you guys get tired when these start running long, these lessons start running long. So what I'm going to do is I'm going to show you how to plot live data, and then I'm going to give you an assignment to connect that then to the Arduino project that we're working on based on what you've learned in the earlier lessons on Wi-Fi and UDP and such things as that. Sound good? I hope it does. So I've done way too much talking here, and it's time for us to jump in and begin to code. So we will go to the code view. We'll also get a sip of our coffee to get ready here to go on this thing. I also need to get out of your way. Now, we're going to have to add another module to PyQt 5 that will allow us to plot data. So I need you to come over here to Tools, and then you're going to go to Manage Packages. And then what you're going to do is you're going to search on PyQt Graph. Pretty obvious, isn't it? PyQt Graph. And then let's see if we can find it there. There it is. PyQt Graph. We'll click on that, and then we're going to say install. And it takes just a second. More than a little bit of a second here. Okay, there it goes. That wasn't too bad. Now, the first thing we always want to do is just actually see if we got it. So I'm going to say import PyQt Graph as PG. That means that when we want to use it, we just do pg.this and pg.that. Now let's run that thing and see if we get any errors, and import it. So that's good. So we got the library. Sometimes getting your library working is half the battle, and we've got that done. Now let's go ahead and import the other things we're going to be using. And so I'm going to say from PyQt 5.qt widgets, I'm going to import everything, star. Then from PyQt 5.qt core, I'm going to import everything. And then I'm going to say from PyQt 5.qt GUI, I'm going to import GUI application. Now, I bet you thought I was going to import everything, but this one, the importing star, it didn't work exactly like I was expecting. So I got QGUI to QGUI application with one L. Doesn't count as a mistake if you catch it before you run it. Then we know that we have to import sys from our earlier work. We need to, from math, import sine and pi. And then just for good measure, we're going to import time just in case we need it. All right, so let's run this, make sure all those libraries are good. No, we have a QGUI application, QGUI uppercase G application. That's why we always run it as we go. Okay, that looks happy, and so that looks like good news. Okay, so what are we going to do? I'm going to teach you how to graph something. And rather than set up a barometric pressure project over on the Arduino and then be importing that data and then graphing it, today I'm just going to show you how to graph data. Then in future lessons, we will bring that to life using the data that's coming in from the Arduino. But I'm trying to keep these lessons to be a little bit more manageable and a little bit less tedious. Okay, so now, if we are going to create a sine wave, there are certain things. Remember the sine wave, we've done them before. They go up to 1, they start at 0, they go up to 1, they go back to 0, they go down to -1, and they come back to 0, and that is one cycle. Well, if we're going to work with a sine wave, we have to define the period. And the period is how long in seconds it takes to make that full trip, to make one unit of the sine wave go up, back to 0, -1, and back to 0. That is one period. How long do we want that to be? Well, we want to see it. We don't want it to go at megahertz. We want to see it. So I'm going to say the period is going to be equal to 5 seconds, like that. And so it'll take 5 seconds to work its way around. And then we can change that and we can play with that and try different things. Well, we like to think in period, like how long does it take for one cycle to occur? That's the period. But there's another very important concept, and that is the frequency. And the frequency is like how many times you make that period in 1 second. So it's the cycles per second. So what is that? Well, the frequency is very easy. It's 1 over the period. So what I like to do is I like to choose the period and then have it calculate the frequency. Other people say, oh, well, I want 5 hertz or I want 25 hertz. And then from that, they calculate the period, and the period would be 1 over the frequency, or the frequency would be 1 over the period. And so you can kind of do it either way, but I'm choosing a period of 5 seconds. So what is the frequency? The frequency would be 0.2. You're making 0.2 of a cycle every second. Okay, hopefully that makes sense. Now we also have to decide the number of points that we want. And so I like to create a smooth sine wave. I like to have, a couple hundred points. Let's say num points. Let's see if we can do 500 points. And so in this one sine wave, I'm going to calculate 500 points to create that, and that's going to be a very, very smooth curve, a very, very smooth curve. Now, practically, kind of like 100 points for a sine wave makes a pretty smooth one, but there's a reason that I'm going to do 500 here, and you'll understand why a little bit later. Now, between each step of the sine wave, how much space do I need between each step? So the time step, the elapsed time, it takes 5 seconds to make the whole one. But what is the time between individual steps on the sine wave? Well, that would be the period, the total time, the period divided by what? The num points. Now notice you can't go in like a wild man and just start making up numbers. You can choose the period or you can choose the frequency, but you can't choose both. So I chose the period, I calculated the frequency. Now I chose the number of points, but now the time step I can't choose. That is going to be the period divided by the num points, and hopefully that makes sense. Okay, that's most of the setup there, but there's a couple of other things that we need. Now, if we're going to plot data, we need an array, and that array is going to carry the y values, and we're going to have an array to carry the x values. So we need, and what is our x value on the horizontal axis? It's time. Okay, and then what is our y value? It's the sine of the x value. It's the sine of time. And so I need two different arrays. Now, what am I going to call this? I'm going to make a red sine wave. I'm going to make a red sine wave. So I'm going to call this red data, and that is going to be equal to, it's going to be equal to an array with zeros in it, and then how many elements in the array? Num points. Now, what is this going to do? This is going to generate an array, and that array is going to have 100, or it's going to have 500 elements in it, num points, and each of those elements is going to be 0. Now, I'm also going to need the x-axis, which is going to be time data, and that's going to be the same thing. It's going to be put in a 0. How many times do you want to put it in? You want to put it num points time. Let's run this thing and just make sure we're doing okay. Num points, what was that? Num points. It should be an S, num points. Okay, like that. Now let's run this. Okay, you see why we like to run it along the way? Let me just see, like we have num points, like that. Yep, that's in there. Red data. Yep, that's in there. Whole lot of zeros across there. It doesn't show all of them unless you click that, and then it'll actually show you the whole array. That's like 500 zeros in there. Okay, so that's very good. Now we're ready to go in and start setting up our PyQt 5 window widget layouts and so forth. So where do we always start? We always start with the app, right? You got to have the app. You got to fire up that app, and that's going to be Q application. And then what we need to do is we need to pass it the sig sys arg values like that. Okay, let's make sure that like that. Yep, I think I can pass it nothing like that. Let's see if that works. Okay, yeah, that works too. I think that'll work. Also, we have to still import sys though, because that closeout statement, that last line of code does, I think, call the sys. So we do have to have this imported for wrapping the program up at the very end. Now we have our application. Now what do we need? We need our window. So I'm going to create something called window, and it's going to be my Q main window, like that, Q main window. Now I'm going to need a window dot set window title, and then what am I going to want? I'm going to call this my red sine wave graph, like that. Okay, so that should be the title. Now I need to do a window dot set geometry, like that, and I want it 100 over, I want it 100 pixels over, I want it 100 pixels down, so it's from the upper left of your screen, you go over 100, down 100, then I want it 800 pixels wide, and I want it 600 pixels high, and that's a pretty good window for me. Now these two commands you don't have to put in for yours, but for me, I have 4 screens, and this one pops up at a random screen over here, and I want to move it to the screen that you're looking at, and that way every time I don't have to move the window. So I'm going to create an object called screens, and that's going to be Q GUI application dot screens. So I create this object screens, and then I'm going to window, the window that I created, I'm going to dot move it, and then where am I going to move it? To screens. Which screen? Screen 1. Dot, now I've got to give it the geometry, okay, like that, and then dot X, and then plus 100. So I'm going to come to screen 1, and now I'm going to move over 100, okay, and then I'm going to take this whole thing again. I hope I don't have a mistake in there, and I'm going to paste it, Okay, and this time it's going to be geometry.y, like that. Okay, and then plus 100, and then we need to, oh, you're not seeing that. Let me get out of your way. It's just copying and pasting, but I know you don't like that when it's behind my head. Okay, like that. Let's see if we'll get a window. Okay, now what I need to do, though, is let's come down to the very bottom of the program and let's finish the program so we don't forget to do that. So what I need to do is I need to wind up the program by doing a window.show and then a sys.exit of the app.exec underscore like that. Sometimes you don't want to ask why. Sometimes you just want to do what you're being showed there, because I don't want to spend 30 minutes explaining what that does. But that kind of closes the program out. So let's see if we get something here. And boom, what do I get? I get a I get a window, and notice how the window came to this screen. I didn't have to move it over here, and I got the title on it. So far so good, man. We're doing pretty well here. Okay, now everything needs to be between this command and this command. So I've got a window, I've got it in the right place, and then I've kind of wrapped the program up down at the bottom. So now we just got to kind of fill in the details there, all right? So a couple of more bookkeeping things. I've got the screen. Now what do I need? I need a widget container. That's what I call it, because that's kind of what it is. You can call yours whatever you want, but what is that? That is a Q widget, like that. All right, then I want to window dot set central widget, and then what is that going to be? The widget container. So here I'm saying that that widget container that I just created is going to be the central widget of the window that I created up here. So I create the window, I create a container, and then I tie that container inside that window. So after you do this a little while, it kind of starts making sense. It's like this onion that you've got different levels at. Outer level is app, next level is window, next level is the widget container. So now I got a widget container. I'm feeling pretty good. Okay, so now we've got that window set central widget container. Now inside that container, I've got a place to put the widgets, but now I need to define a layout so that as I begin to put widgets in there, they don't just go in random places. I define a layout. So I'm going to call this my main layout, and that's going to be equal to a Q and then V for vertical. So those widgets I want to stack vertical QV, and it's going to be a box layout in there. Now in where? In widget container. Okay, so widget container is going to go into my main layout box. Okay, or I guess what I should say is the widget container is going to stack things according to my main layout box, if that makes sense. Again, the layout box is another level of the onion that's underneath the widget container, which is underneath the window. Okay, by underneath I mean in a lower level. All right, so I've got my main layout. I think we're ready to start graphing. So I'm going to say, I'm going to create something called plot widget. Okay, plot widget is going to be equal to the object that I'm going to be interacting with to create this graph. I'm going to call it plot widget, and that is going to be a pg.plot widget graph. So you see, this is the library, this is the method, and this is what I named my my particular plotting widget. And I usually don't like to call things the method, and I'm seeing that I did that, but this is an uppercase P and this is a lowercase p. But if you name your object the same thing as your method, you can sometimes get in trouble with that. Now, I want to put some labels on this thing. So what is the thing? It is the plot widget. What do I want to do? I want to set the label, And then what are the labels? Well, I need a left axis. So I'm going to say, what do I want my left axis to say, right? That's the y-axis. I want that to say, that's where it is. It's on the left. And what is it? It is going to be, I'm going to plot y is equal to sine of 2 times pi times f times t. Okay, that is the label, and that is the label because that is what I'm going to plot. Y is equal to sine of 2 pi ft, and that will create our sine wave. This isn't creating the sine wave. This is just the label. Okay, now if I have a left label, what else am I going to need? I'm going to need a plot widget dot set label. And what do I want? I want the bottom label. So this would be like the x-axis. And then what is this going to be? I'm going to just call it time. And then I'm going to put in seconds. You know what it is there, like that. Like that. Okay, so that's my bottom label. Now my plot widget dot set title is going to be my fine sine wave. Okay, my fine sine wave. And really, usually sine, you put it S-I-N like that, and then some people think my fine sin wave, but we will assume that most people will sort that out. I see that I'm still remaining rather small over there. I think I will come back to a more viewable size on myself there. Okay, now so I've got the set title is the sine wave. Now what I'm also going to do is I'm going to plot widget dot add legend, and that is if I'm putting multiple graphs on there, each one will have kind of a color code and a label on it. Okay, and so we'll have a legend on this. Okay, add legend, that looks good. Now I've got to do the main layout dot add widget, and which widget? The plot widget. Now do you see the hierarchy here? Do you see the hierarchy? I just created plot widget. Plot widget is going to go in main layout. Main layout is inside the widget container, which is inside the window. Okay, and once you start playing with this a little bit, it really does start making a lot of sense. Now, this isn't going to plot anything, but let's just see if we can kind of get something up here if I run this. Okay, look at that. Okay, I've got the my fine sine wave, and I've got the y data going from 0 to 1. Well, it's just kind of making things up, and here's 0 to 1. It doesn't have any data, so it doesn't really know where to put things, but hey, we're getting a graph. We're getting a graph. So now I've got that created. Now, ladies and gentlemen, we're going to need some data. So I'm going to create that data. And I'm going to create the data because I don't want to go in and have to do all of the UDP Wi-Fi to connect it to the Arduino to get data. So we're just going to make up some data. So for I in range of num points, like that. Now remember, it's going to stop 1 before num points, which we want it to do because if it starts at point 0, if it starts at index 0, index 499 will be the 500th point. So we want to go all the way to num points, and it will stop 1 before that, which is what we wanted it to do anyway. So at first it's very confusing, but then it makes a whole lot of sense in the end. So now what is the time? The time is going to be equal to I times time step. Okay, so the first time through, I is 0. So what's the first time that we start with? Time equals 0. That makes sense. And then the next time, I'm going to be over by 1 time step, which is going to be the period 5 divided by 500. And so that's going to be like 0.001, like 1 millisecond. So time step is 1 millisecond. So each data point is going to be spaced at 1 millisecond based on my num points in my period. Okay, but this will create then my time array, And then what am I going to do? I'm going to say my time data, the array that we created of I, is going to be equal to t. Now you could have said, well, you could have just done time data of I, but I kind of like to do things this way. And maybe in the next line of code, you'll see. So I now have the time data. Now I need the red data, which is the sine wave, the red data of I. The red data of I is going to be equal to sine of 2 times pi, and we imported that pi so it'll know that it's 3.141592654. It's going to know that. And then times what? Times the frequency times the time. And that time was that last time that I did right there. Now I'm going to build that sine wave, 2 pi frequency t. Okay, that actually looks pretty good. So now what am I going to do? I am going to say my red plot. Okay, remember red data is the data array. Now I'm going to create an object, my red plot, and that's going to be equal to my plot widget that I just created dot what method dot plot. And then what do I want to plot? I want to plot my time data. It's expecting an array, so just give it the name. Don't put brackets or curlies or parentheses on it, just time data and what? Red data. I'm passing it the x-axis and the y-axis. Time data and red data. Okay, now let's snazz it up a little bit. And what I want to do is I want to tell it to use a certain pin, and that pin is going to be equal to pg my library dot make pin. And then what pin do I want? I want a red one, so I'll put R, and I want the width equal 3. And I'm going to have to get out of your way again. So that's a little bit of a fat line. A 3 is a little bit of a fat line. Okay. And now, remember how we did that legend? I need to give this a name, and the name is going to be red. And that is what will show up on the legend. So remember, it's going to plot the sine wave, and then it's going to have a little red line, and then it needs a word to put there on that red line for the legend, and that is going to be red. Okay, that looks pretty good. Okay. I'm a little afraid now. I'm a little afraid. Okay, let's run this thing. Boom! First try. Look at that. All right, look at this. So remember that word that we added, red? And so now I have this little red line, the legend, and the title for that graph is red. The title for the whole graph is my fine sine wave. And then up here, the window title is red sine wave graph. And then here we have y is equal to sine 2 pi ft. And here we have time as seconds. So you see, you can create an array. You need an X array and you need a Y array. Usually for the things we're doing, the X array is going to be time and the Y array is going to be some value, and then you can plot it rather easily. You want to plot something different? Just create different data. Pretty good, huh? Now the astute amongst you out there might be saying, hey, wait a minute. Hey, you said you were going to plot live data. This doesn't look like live data. Okay, it's pretty easy to graph something, but it's a little bit harder to plot live data. So what do you think? Do you guys have the energy? You want me to bring this thing to life right now? Can you endure just a little bit more, and let's bring this graph to life? I hope you can, because we're going to bring it to life. Okay, so we plotted it one time, and you want to still plot it one time. You put the first one up there to get you started, but now what do I need? I need a function. I need a function input. Okay, that looks good. So I'm going to define a function called update, update graph, like that. Okay, and now I'm going to make a global variable of t, the time. All right, of t, the time, give me a little bit of time here. I got to think, okay, I'm going to bring this last time down. I want to keep track of that. And now what I'm going to do is I'm going to say the next time, because I want that last time from that first graph that I made. I don't want to start over at 0. I want that last time that we created. And now the next time that we use in this function is going to be that t is equal to t plus time step again. What am I doing? I'm starting off, I'm starting where I left off on that original graph. Otherwise, you get a glitch. The graph comes up and then you glitch as you go to the live data. So if you stop to think about that a little bit, hopefully it makes sense. Now, r is going to be equal to what? This is just going to be the red value, and that's going to be a what? Sine the function of 2 times pi times frequency times time. Okay? Like that. R is equal to 2 times pi times frequency times time. Okay? Now, let's keep going here. All right, so now what I'm going to do is I'm going to say for I in range, and I want to go to num points minus 1. Now, why num points minus 1? What I'm going to do is I already have a complete red data curve, and I already have a complete time data curve. But what I want to do is I want to move every point 1 to the left, and then that last point I want to replace with these 2 new points. So everyone's going to get scooted 1 point to the left, and then the new points are going to go on the end. Well, now the last data point would be num points minus 1. This is going to stop at num points minus 1, one before that, num points minus 2. But that's because the last point I want to move to the second to the last point. So where do I want to start? Where do I want to end? At the second to the last point. And if that doesn't make sense, pause it and think about it. I want the last point to move to the next point over. And the last point is num points minus 1. I want to move it to num points minus 2. And in this crazy scheme, num points minus 1 will actually be num points minus 2 because it stops 1 before num points, and now this makes it 2 before num points. Stop, have a strong drink of coffee, and listen again if you didn't understand that. Okay. Now, what do I say? Red data of I is going to be equal to red data of I plus of I plus 1. Like that. I'm having trouble with this line of code. Now, time data of 1 is going to be equal to, and I like to space these things out a little bit, is equal to time data of I plus 1. So what am I doing? I'm taking time data of I plus 1 and scooting it over 1 backwards, right? I'm scooting it over 1 backwards. So it's going to start at 0 because the range starts at 0. So it's going to take red data of 0 plus 1, red data of 1, and it's going to move it to red data of 0. And that should have been an I there. And man, that would have been a hard one to debug. Okay, so it's taking the first point and moving it to the 0th point, going all the way to the last point and moving it to the second to the last point. All right, but now what is missing? That last point is missing. So I need to say red data of num points minus 1 Okay, why? Because the 500th point is at an index of 499, so I've got to subtract the 1 here, and that's equal to red. That is putting it in the last place, the 500th number in the 499 index. And then time data of num points minus 1 is going to be equal to, who is our friend? That t that we just created. Okay, so the whole purpose of the for loop is to move every data point over by 1, and then we take our new red data, put it in the 499th position, and our new time in the 499th position, which is actually the 500th number. Okay, I'm not going to say it anymore. If you don't understand it by now, then I can't help you. Okay? All right, so this is starting to scare me now. I'm starting to get very, very scared. All right, so now what I'm going to do is I'm going to say red plot dot set data time data dot red data. So I've already got that object, which is the red plot. That was that graph. Now I'm going to change the data on it to time data and red data, which have been updated. And what's that going to do? That's going to take that graph and it's going to move it to the left one, because every point went to the left one, and then I added a new point on the end. And then as I call this thing, it's just going to continue to move to the left. Now, what is the problem? Like if I ran this right now, first of all, I might have an error in here somewhere. Okay, and I get this graph and nothing is happening. Why is nothing happening? Okay, I've got this function that will update the graph, but I'm not calling the function. So what you might think about is you might think about doing something like while true and then just sit and call that, but you can't do that. You see, this is not exactly what you would think a normal Python program. You have set things up and those things are running on their own, and you can't come in and really mess up the timing. You've kind of got to let the thing run itself, so you can't go in and put delays and while loops and things like that. But what I can do is I can create a timer, and that's going to be a Q timer like that. Okay, and then that timer, I need to set the time out connect. Okay, so I'm going to create a timer. When that timer reaches its time out, what do you want it to do? You want it to connect to, wait for it, update graph, like that. Now, what do we not know? We don't know the time out. Okay, so what am I going to do? I'm going to say timer and start, like how long do you want to run that function? Well, every time step. What is every time step? It is time step. Now the problem is this wants the call in seconds and time step is in milliseconds, right? Time step is in milliseconds. So time step is in seconds. I spoke wrong. Time step is in seconds, and this timer it wants in milliseconds. So to go from seconds to milliseconds, we need to multiply by 1,000. Now we are in the same units. And now the problem is time step was something divided by something or another. So this might not be an integer, and this has to be an integer, so I have to make it an integer. Okay, so what would this be? This would be something like, what did we say that the time step was the period 5 divided by 500? That would be 0.01, something like that is what it would be. And then that is what we are defining as our time step here. I might have said a millisecond before, but I think it's 0.01, not 0.001. But nonetheless, it's going to work here. Now, what we want is this time we want to see no errors and we want to see a moving graph, okay? Boom! It's alive! It's alive! Look at that. Okay, I promised you plotting live data. I delivered to you plotting live data. And so look at that. That is absolutely amazing. Now, the question is, I said I wanted to run this like every 10 milliseconds, I believe is what that would be. 5 divided by, I really think that would be 10 milliseconds. This is running every 10 milliseconds and it's looking great, but we have to ask ourselves a question, and that is this in real time? Does it really have a period? Does it really have a period of 5 seconds? It's going by, like if I go 52, 53, 54, 55, 56, 57. That does sound like seconds ticking by there. But what if I'm plotting 500 points and I'm doing that like 100 times a second? Can that graphing routine really keep up, or is the computer time falling behind real time? So we want to see, are we really getting in the real world on a real clock? Are we really getting a 5-second period? So we need to instrument this code. We need to put some instrumentation in this code. So up here, before we start, I think I want to go ahead and I want to start a timer here. All right, so I'm going to say timer start. I'm just going to grab the time here, and that is going to be equal to, you might think of doing time.time, but I want to do performance counter, and this is a little more accurate because I'm running through this thing very fast, and if there's a very small error, that error could pile up. So I'm going to try to be as accurate as I can. So this is going to be a real time that you grab from the clock, and I do believe it is in milliseconds if I'm remembering this right. So the T start is going to be there, okay? And now what we're going to need to do is, I think, I might have to play around with this a little bit. So what I want to know is, how long does it take to make one complete cycle? Okay, how long does it take to make one complete cycle? So you could say, well, you could call the cycle right when you reach 1, and then wait for it to reach 1 again, and then take that as your time marker. But the problem is when you're using floating point numbers in that sine function, what if it didn't get to 1? What if it said 0.999999999? You see, floating point numbers, it's hard to say when something equals something because floating points are hard to work with in that way. So I don't want to do that. And same thing with -1, and same thing, well, what when it's at 0, what if it doesn't hit 0 exactly? And so the way I want to look at it is, how do I want to look for that point. I want to look for that point that this data point is less than 0 when the next data point is greater than 0. And so if this one was less than 0 and the next point is greater than 0, then that is going to be between those 2 points I cross 0, and that's where I'm going to flag my timer. Okay, so I'm looking at that point that I cross the x-axis, I cross the y equals 0 point. Okay, right when it crosses 0 is when I want to grab it. So I'm going to say if red data of 0, that first element in the array, if that first element is less than or equal to 0, and if red data, the next data point is 1, so between the 0th element and the 1th element of the array, if you cross the y equals 0 point, then what do you want to do? So if that is greater than 0, I should have said that, finish that on out. Okay, so if you're less than or equal to 0 on this point and greater than 0 on this point, then that is when you go in and do your timing business. Okay, so now what I'm going to say is, I'm going to create this thing that I am going to call my measured, where is that? I'm going to call that my measured period, and that's going to be the present time, which is going to be time.perf counter, like that. So we drop in here, and then what do I need to subtract? I need to subtract the starting time. So this is when we go into the function the first time, and I need to subtract that off time, or t start, like that. T start. And just to be safe, I think we better make that a global variable now because we're using it down here, t start, like that. Okay. And just to be safe, I better put the frequency as a global variable too. Okay. Those it should know. And so now the measured period is going to be my present time when I hit that magic point of crossing the y = 0 point, crossing that x-axis, minus where it was when the loop started. And that should be the period. Okay. Now what I'm going to do in here is I'm going to say print the measured period. Why do I call it measured period? Because there's the period that I want, that I asked for, and this is the period that I got. And so this will be measured period, like that. Okay. Now, what we have to see is that it's going to come into this loop again on the next cycle. So I need to reset my t start to the present time, which is time.perf _ counter. This instrumenting your code, it's really an important thing, and so don't just copy me. You really need to make sure that you understand what I am doing, okay? You really want to make sure that you understand what I am doing, and I've tried to explain it carefully. So every time we make one complete cycle, it's going to drop into here and it's going to report the elapsed time. And we hope it's 5 seconds, but if it's like 14 seconds, we know that we're running slower in the program than what the clock in real life is running. So let's go ahead and run this and see what happens. And you guys be watching down here because the period should show up down here, okay? Boom. Okay, we got the graph. And I am not getting period 5.2 seconds, okay? So this isn't perfect, but 4.998, that's like really, really good. And then the period 4.99. So that first one wasn't perfect because probably that first t start wasn't perfect. But now look at this. We are achieving in real life precisely a 5 second period. Okay. Now let's play around with this. Let's come in and let's say that I want to make a period of 1 second. So that's going to be going up and down a lot quicker because it's going to make the complete cycle in 1 second. So let's see what happens here. Okay. And when we run that, look at that, look at that. But I wanted a period of 1 second, but now it is achieving a period of 3.2 seconds. That means the software is not updating fast enough. What does that mean? I am asking for too many points because when I was here at 5, I was processing 500 times in 5 seconds. That means I am doing 100 times through that loop in a second. So 500 times through the loop in 5 seconds would be like 100 times in 1 second. But if I just change this to 1, now I'm not asking it to do 500 times through that loop. In 5 seconds, I'm asking it to do 500 times through that loop in 1 second. And what do I learn? It can't keep up. Well, does that mean I can't have a period of 1? No, that means don't be silly. Don't try to have 500 points on one sine wave in a second. What would be something good? What if we did 100? Because what we saw is 100 times a second would work pretty well. And so now let's look at this. Okay, it's going by fast and boom, 0.91, just exactly right. Okay, just exactly right. So that is working really, really great. So now you tell me, what if I want a 20 second? What if I want a 20 second? what should I set this to? Well, 20 times 100. We know it works very nice at 100 points a second. So 20 times 100 would be 2,000. And I'm going to predict that this is going to work pretty well. Okay, let's take a look. Now, it looks like it's going slow, but we said what? We said we wanted a period of 20 seconds, so it should go slow. The question is, what is it going to read for the period when it comes down here? Be patient. Be patient, my friend. And as it crosses over there on the right, it should be, boom, 23 seconds. Don't worry, let's let it go again, and let's see if the next one, sometimes, you know, that first one wasn't exactly accurate, but 23 is like 10%. That's not terrible, but I'm hoping that the next measured period would be a little bit better than that. But let's see. Okay, 22. This error might come down if you let it run. Now, I'm a little bit surprised. 20, that would be 100. So that does look right, but we didn't quite get the accuracy there that we had hoped for. But let me show you something that's a little bit of a surprise. Let's go back to 5 seconds, and let's go back to 500, and now let's run it. And what I want you to see is at 100 points a second, 100 operations a second, it's just that absolute sweet spot where we are getting, look at that, 5.05. That is really, really very, very accurate. Okay, that is very, very accurate. That's better than 1%. That's much better than 1% on the accuracy. Why? Because we're not trying to run it faster than Python can process all of that graphing, process the graphics, process the moving the points over and all that sort of stuff. But now here can be the surprising things. Well, let's be really safe, and let's just do 100 points, and now this would only be 20 points a second. So that should be much easier, right? That should be even more accurate because we're giving it less processing, so we expect an even better answer. But what did we get? We got a worse answer. 6.3 is worse, even though it should be faster. And this is what you guys have to see. Python is notoriously poor in its timing and its use of time. So it is not reading off of a real-time clock somewhere. It's just sitting there kind of counting. And if your PC is out running out and checking the internet, like running out and downloading your latest weather data or something, that can affect your timers. So anything that you're doing on your PC can affect the accuracy of your timer on this thing, because remember, this is running on your PC, Python on your PC. You're not using a real-time clock, therefore anything can happen. Well, the strange thing that I found is for almost any period, if you run this thing at about 100 operations per second on your update rate of updating the graph, that is the sweet spot, and that is where things run the best. And so we're going to go 5. We're going to go back to 500, so that would be 100 a second. And that, for some reason, is really the sweet spot. Now, I ran into the same thing using Visual Python, VPython, and, you know, you're updating animations. And updating them slower did not necessarily mean that they were updating more accurately, that there was that sweet spot in timing that they're about 100 updates a second was that point that everything ran the smoothest. And so it's one of the downsides of working with Python. You remember when we were on MicroPython on the Raspberry Pi Pico W, we could solve these problems, these timing problems, using the state machines, but we don't have state machines on the PC. So in Python, you just got to kind of live with the non-perfect timing. But when you tune things up, you can see that we are doing things really, really accurately here. Now, what is your homework assignment? Okay, your homework assignment is now, I showed you how to graph, I showed you how to graph live data. And then what I was doing though is I was just generating it. Now I want you to connect this to your Arduino. And so what your homework assignment is to do something like this. So what I am going to do is I am going to run my software, hopefully. Okay, now what I want you to see is that didn't work the way I was expecting it. Hold on, let's see. Minor glitch, minor glitch. Maybe I need to reset this. Okay, and now let's see. Okay, now what I want you to look at this LED, and the brightness of the LED is being controlled by that sine wave. Now watch, as the sine wave is up at the top, it's coming down 0, it's off, and then the brightness starts coming back as it starts going up. And so I am creating a sine wave on my RGB LED. Now we're probably going to continue to go with these lessons, and so just understand those are 1000 ohm resistors, and if you want to keep things up with the way I'm doing them, I'm using RGB as pins 9, 10, and 11. You want to be using those squiggly ones. And also let's see if we get to where we really want to be. Is I'm going to unplug this. Okay, I'm going to turn it on. Okay, I'm going to reset the server here, and now this is completely untethered, and let's see if we can get that to work. And boom, look at that. Operating, completely mobile, controlling my Arduino project from my slick, super duper widget GUI PyQt 5. Okay, guys, I don't know, maybe I'm just an old man and it's easy to excite me, but I think this is really, really cool. Now you do see what we're doing here is, so what your homework assignment is to bring your project alive by setting up that UDP UDP server here and make this a UDP client. Also, I want you to see that part of the assignment is you are to operate at 5 Hertz and 500 points per sine wave. Okay, 5 Hertz, 500 points per sine wave. Do you see that? 5 Hertz, 500 points per sine wave. And this is the thing that you might not notice, but was very important. Now watch this. Watch this, okay? All right, what do you see here? I am getting 5 Hertz in real time. I mean, yeah, I'm getting a period of 5 seconds in real time. I'm getting a period of 5 seconds in real time. So if you look at this, it's going up and down in exactly 5 seconds. Okay, do you see how accurately that is doing that? Okay, that's what you have to do. You have to make it run in real time over Wi-Fi, over UDP, where you're transferring 100 commands a second. Okay, so you might have to play around with it a little bit to get that to work. But anyway, that is your homework assignment. And guys, I hope that you are having as much fun taking this class as I am making it. I am actually having a lot of fun with this PyQt 5 and this UDP and this Wi-Fi business. I'm actually having a lot of fun with it and hope you are too. It's at this point that I always want to give a shout out to my Patreons. It is the support that comes in from my Patreon partners that allows me to continue to make this fresh new content every single week. Thank you guys that are supporting me. You can also help the channel by giving this video a thumbs up and leaving a comment down below. That will help me with the old YouTube juice. Also, be sure to subscribe to the channel. When you do, ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later. Look at that. 1, 2, 3 boats back there. Wow.